The chariot for this cosmic journey is a colossal vehicle named Starship. Forged from stainless steel in the Texas sun, Starship is designed to be the world's first fully and rapidly reusable rocket. It's a two-stage system, bigger than the Saturn V rocket that took astronauts to the moon. The plan is audacious: launch thousands of these ships carrying people, supplies, and even Tesla's Optimus robots to Mars. The robots would go first, preparing the initial habitat and infrastructure, paving the way for the first human pioneers. Musk's timeline is aggressive, with hopes of sending an uncrewed mission as early as the end of next year, 2026, to take advantage of the favorable alignment between Earth and Mars. However, the path to Mars is littered with wreckage. The history of Starship's development is a dramatic cycle of spectacular launches followed by equally spectacular explosions. This year alone, 2025, has been tough. Test flights in January, March, and then again in May all ended in what SpaceX euphemistically calls a rapid, unscheduled disassembly. That's a fancy way of saying the rocket blew up. These failures are not just technical setbacks, they are public spectacles that cast doubt on the feasibility of Musk's timeline. After the May 28th failure, SpaceX even had to cancel a major presentation about its multiplanetary vision, a clear sign that the technical reality was not matching the public relations schedule. Musk, however, operates with a philosophy that embraces failure as a necessary part of innovation. He sees each explosion not as a disaster but as a data-gathering opportunity. His approach is to build, fly, fail, fix, and repeat as quickly as possible. Where traditional aerospace engineering might spend years on ground simulations to avoid any failure, SpaceX builds and launches, learning from the real-world stresses on the vehicle. This iterative process, while costly and explosive, allows for much faster development. Musk remains publicly optimistic, promising to increase the pace of test flights, believing that each fireball brings him one step closer to a successful landing on another world. This pattern of bold promises followed by delays is not new for Musk. We've seen it before. He once promised private citizens a trip around the moon by 2018 and humans on Mars by 2024. Neither has happened. The Tesla Cybercab, a futuristic robotaxi, was unveiled in 2024, years after its initial promise, with mass production now pushed to perhaps 2027. This history of missing deadlines makes it difficult to know what to believe. Is he a visionary who sees a future so clearly that he underestimates the journey, or are these timelines a tool to push his teams and the public to believe the impossible is just around the corner? Beyond the exploding rockets, there are immense scientific and engineering hurdles that SpaceX must overcome. One of the most critical is orbital refueling. A single Starship cannot carry enough fuel to get to Mars on its own. The plan requires a Starship to launch into Earth's orbit and then be met by multiple tanker Starships that will transfer propellant to it before it begins its long interplanetary journey. This has never been done on this scale before. It's a complex orbital ballet that requires perfect timing and flawless docking, and SpaceX has yet to demonstrate this crucial capability. Without it, the entire Mars architecture simply does not work. Then there is the human element. A trip to Mars is not a quick jaunt to the moon, it's a grueling 6 to 9 month journey through deep space. Astronauts will be exposed to dangerous levels of cosmic radiation, far from the protection of Earth's magnetic field. They will also have to endure the psychological strain of being confined in a small space for months on end, with no hope of a quick return. Once on Mars, they will face a hostile environment with a thin atmosphere, extreme temperatures, and pervasive toxic dust. Keeping a small group of humans alive, healthy, and sane on Mars is a challenge that makes building the rocket almost seem easy by comparison. Interestingly, Musk is not entirely alone in his Martian ambitions. NASA, the American Space Agency, is also methodically planning its own journey to the Red Planet, though on a much more conservative timeline, targeting the 2030s. In a fascinating twist, NASA is actually a key partner for SpaceX. The agency has selected a modified version of Starship to be the vehicle that will land its Artemis astronauts on the moon, hopefully as soon as 2027. This makes the moon a critical stepping stone, a dress rehearsal for both NASA and SpaceX. The success of the Artemis lunar landing will be a major validation of the Starship technology. This partnership creates a dynamic duo of space exploration, the slow, steady, taxpayer-funded government agency, and the fast, disruptive, privately funded Billionaire. NASA brings decades of experience, scientific rigor, and a focus on safety. SpaceX brings speed, innovation, and a willingness to take massive risks. While Musk dreams of a million-person city, NASA's goals are more focused on scientific exploration. Together, they might achieve more than either could alone. NASA's funding provides SpaceX with crucial capital and credibility, while SpaceX's technology could accelerate NASA's own long-held plans to get human boots on Martian soil. So we come to the ultimate question: is Elon Musk's Mars dream a realistic vision for the future of humanity, or is it the grandest fantasy of a modern-day pharaoh? The answer, as of today, is complex and uncertain. The sheer scale of the challenge is difficult to comprehend. It requires not just a reliable rocket, but a revolution in manufacturing, life support, robotics, and energy production. It requires creating an entire industrial base on another planet from scratch. The physics are daunting, the economics are staggering, and the human challenges are profound. It is, without a doubt, the single most ambitious project ever conceived by a human being. On one hand, it's easy to be cynical. Musk's timelines have consistently proven to be wildly optimistic. The repeated failures of Starship test flights throughout this year serve as a constant, fiery reminder of how hard spaceflight truly is. The idea of a self-sustaining city of 1 million people by the 2040s seems less like an engineering plan and more like a mythological quest. Critics argue that the immense resources being poured into this Martian dream could be better spent solving urgent problems here on Earth, such as climate change, poverty, and disease. They see it as an escape fantasy for the super-rich, an act of colossal hubris. On the other hand, history is full of ambitious projects that were once dismissed as impossible. The desire to explore, to push boundaries, and to reach for what is just beyond our grasp is a fundamental part of the human spirit. Great leaps forward often require someone with an obsessive, almost irrational level of determination. Musk's relentless drive has already revolutionized the space industry, drastically lowering the cost of access to orbit with reusable rockets. Even if he never reaches his ultimate goal of a city on Mars, the technological spin-offs from his quest in reusable rocketry, life support, and solar energy could have transformative benefits for life on Earth. In the end, perhaps the value of Musk's dream isn't just about whether it succeeds or fails. Its true power may lie in its ability to inspire. It forces us to look up from our daily lives and consider our place in the universe. It challenges us to think on a grander scale, to ask big questions about the future of our species. Will humanity remain confined to its cradle, or will we venture out into the vastness of the cosmos? Elon Musk has placed a monumental bet on the latter. Whether his dream becomes our reality remains to be seen, but in trying to reach for Mars, we will undoubtedly learn a great deal more about ourselves right here.